In this video, we are going to review diamond problems and GCF, or greatest common factors. So, starting with diamond problems, if you are new to Central York School District, this is going to be something new. It is not super difficult. It's actually kind of fun, and we're going to kind of walk through how to do these problems. So, you are going to look for a pattern. So for example, for problem 1, it says look for a pattern in the first 3 diamonds below. For the fourth, explain how you can find the missing numbers if you know the 2 numbers on the side. So the way diamond problems work is that you are taking the 2 side pieces, so you're going to take your 5 and your 2. You are going to multiply to get the top, and that's where the 10 comes from. And then you are going to add them to get the bottom, and that's how we get 7. So 2 times 5 is 10. 2 plus 5 is 7. So if we take a look at the second example, it's the same process. We take the 2 side parts, we multiply them to get the top. So 2 times 3 is 6. We add them to get the bottom. 2 plus 3 is 5. So we're going to add in some negatives. Process still works the same way. -1 and -4, when you multiply them together, you get +4. If you add them together, you get -5. So the 2 side pieces multiply to get the top, add to get the bottom. So for this last one, I'm just going to put a multiplication and then a plus sign. So looking at our examples for letter A, actually letter A is just like the problem above it. So we are given the 2 side pieces. You have your 2, you have your 5, so they're going to multiply to give us 10 and add to give us 7. Oof, it's a rough looking 7. All right, problem B. We're taking -2 times -1, which will give us a +2, and then the bottom of the diamond becomes a -3, because -2 plus -1 is -3. So problem C, we're changing it up a bit. We know the multiplication and we know the addition. We're missing the 2 side pieces. So we need to think what 2 numbers multiply to give us 8, but also add to give us 6. And you could try a couple things. You could say, all right, 1 times 8 gives you 8. 2 times 4 gives you 8. Those are the only 2 options. Well, 1 plus 8 is not 6, but 2 plus 4 will give you 6. So our 2 missing side pieces are 2 and 4, and order doesn't matter. So if you had these reversed, that would be okay. All right, letter D. We have the top is 4, and we have the side is a half. So we know that these 2 parts multiply to get 4. So if we want to work backwards, we're going to take 4 and we're going to divide it by a half. Or you could divide it by 0.5, same thing. So when you take 4 divided by 0.5, or if you take 4 divided by a half, it ends up giving you the number 8. And if you're not sure, you can check. 8 times a half will give you 4. So now that we know this side's 8 and this side's a half, we're going to add them together to get 8.5, or 8.5. Okay, last one that we're looking at here for this example. We know the top is 12, so we're going to multiply 2 numbers to get 12, but add 2 numbers to get -7. So we need 2 numbers that multiply to give us 12, add to give us -7. Both of these numbers are going to be negatives. So we can make a list of what multiplies to give us 12. So 1 times 12, 2 times 6, 3 times 4, and I believe that's it. So if we make all of these negatives, we need to see which one, when we add them together, would give us -7. Well, that's going to end up being the -3 and then -4. And again, order doesn't matter, so you could have those flip-flopped. So looking at a couple more examples, we have two numbers that we are looking for that when we multiply, we get 15, but when we add them, we get 8. So again, we can make a list. So 1 times 15, 2 is not going to work, and 3 and 5 would be the only other option. That would multiply to give you 15. Again, whole numbers right now. So the only one that's going to add to give you 8 is 3 and 5. And again, order doesn't matter. Those could be flip-flopped. Letter B, we're given this two sides. So we're going to multiply 3 and 1 to get the top, add 3 and 1 to get the bottom. Letter C, we are missing our side. So we do know that the top is multiplication. So we have 5 times something equals 10. So to work backwards, we're going to take 10 and divide it by 5, which will give us 2. So you can check 5 and 2, make 10. And then we'll add them together to get 7. All right, and then the last of the diamond problems, we're throwing in a fraction there. So I do realize that you may not have one of those yellow calculators at home. They made the fractions super easy, so you can kind of just use whatever you have available. So we're going to multiply to get the top. So we're going to take 1/2 times 1/3. And if you want to leave it as a fraction, remember multiplying fractions, you multiply the numerators together. So 1 times 1 is 1. You multiply the denominators together. 2 times 3 would give you 6. So this would be 1/6, or you could rewrite it as a decimal if you wanted to. The decimal would be 0.167. We'd round that off. And then for the bottom, we're going to add them together. So when we add them together, it's going to end up being 5/6, or you could rewrite it as 0.833, which again may be easier if you're using a calculator, especially on your phone, if you don't have one of those nice calculators we had at school. So we are going to skip problem 3. We're going to get into that next week. So this first part is just kind of recapping diamond problems. The second part of this is on the greatest common factor, or what is called GCF. And this is something that you've actually done in years past, I don't know, maybe middle school, 6th grade, 7th grade. And you are going to find what they have in common. So there's a couple ways to do it. I'm going to show you one way, which is using a factor tree. And we are just going to jump right into problem 2. So we're given two things. So first thing, we have our 12x. I'm going to factor it out. Factor means to break down. So with my factor tree, I'm going to just break it down to two numbers that multiply to give me 12. So that's going to be a 2 and a 6. You could use 3 and 4. You could use 1 and 12. It really doesn't matter. Since I factored 12 out, I'm going to cross the 12 out so I don't look at that anymore and think that there's a number there, because I'm factoring that out. So 2 is prime. 2 we can't break down further, but 6 we can break down to 2 times 3. So I'm going to cross out that 6 because I also broke that down. So 12x is actually 2 times 2 times 3 times x. This is what we call the prime factorization. It's broken down, but if you check it out, 2 times 2 is 4, 4 times 3 is 12, and 12 times x is 12x. So it's really the same thing, just in a broken down format. Okay, so now we're going to break down our 40x squared. So again, a couple options. I'm going to pick 4 and 10, but you could pick 2 and 20, 1 and 40. So I'm going to break down my 4 to 2 times 2. So I'm going to cross my 4 out because 4 is gone. And my 10, I'm going to break down to 2 times 5. So again, we're breaking it down to its prime numbers. So underneath my prime factorization of 12x, I'm going to put my 2 times 2 times 2 times 5, because that's what's there. times my xx because of the x squared. So when you have the factor tree, when you're looking at this in a broken down format, you want to see what appears in both of them. I'm very visual. I'm going to circle what appears in both. And again, does not have to be lined up perfectly. But you will see that they both have a 2, and an x. So the GCF is going to be 4x. So looking at what they have in common and then, breaking it down, seeing what they have in common, that's the GCF. Now, could you have found 4x by just looking at the problem? Sure. You could do it that way if you want, if you feel comfortable. But I also like to show people how to write it out just in case they're not sure what they have in common. So looking at the next problem, we're going to start with 18m. Again, you can break this down a couple different ways. Even if you use 2 and 9, you're still going to get the same answer. So I'm going to use 3 and 6. I cross my 18 out because 18 I'm not looking at anymore. 3 is prime. And then my 6, I'm going to break down to 2 times 3. And I'm going to cross my 6 out. So 18m I can rewrite as 3 times 2 times 3. Because 3 times 2 is 6. 6 times 3 is 18. And then I have my m. So I broke down my 18m. Now I'm going to do the same thing with 45mn. Again, I'm going to pick two numbers that go into 45. In this case, it's going to be 9 and 5. I'm going to cross my 45 out. My 9 I can break down to 3 times 3. So I'm going to cross my 9 out. And then I have a 5, mn. So down here, I'm going to write my 3 times 3 times 5, because that's 45, times m times n. Now looking at both the top and the bottom, I'm going to circle what they have in common. Again, it does not have to line up top to bottom. So they have a 3, and an m in common. So the GCF is going to be 9m. So you're looking to see what they have in common, the greatest common factor. If they have more things in common, you're going to multiply them together. That's how we got 3 times m. All right. So the last example here, we have 14n and 42n squared. Again, I'm going to break down 14 to 7 and 2. I'm going to cross my 14 out. 2 is prime, 7 is also prime. So 14n is just going to become 2 times 7 times n. 42, couple of options. I'm going to do 6 and 7. So I'm going to cross 42 out. 6 breaks down to 2 times 3. So I'm going to cross my 6 out. 7 is prime. So 42 becomes 2 times 3, which is 6, times 7, n. And n because it's n squared. Looking to see what they have in common. They have a 2, they have a 7, and they have one n. So if we put that together, if they have a 2, a 7, and an n, the GCF is going to be 14n. So you're looking to see what they have in common. Again, you do not need to do the factor tree if you feel comfortable breaking it down or looking at it, see what they have in common. Stick with the factor tree if you're struggling. If not, just look to see what they have in common.